All right, everyone. Just wanted to take a minute and walk you through a little bit of review. We only have a few lessons left in our Unit 8. So our review is going to ask us to make sure that we are able, to graph these things. So if we are going to be able to graph some of these, I thought I'd just walk through a couple of them. So if you are one of the lucky ones who are paying attention to your homework, I like to do your homework. So I thought I'd do a couple of these. This is your assignment for Monday or Tuesday, depending on which day you have class. First and fifth period, you have it on Monday. And then this is my sixth period, you have it on Tuesday. So what I need you to be able to do is to graph a couple of these things. So we're going to ask you, for all of this information, whenever you see your quiz that's coming in ALEKS, it'll be very similar. Can you tell me what the horizontal asymptote is? Can you tell me what the vertical asymptote is, x and y intercept? And then give me a sketch of the graph. So if you look at the directions, sketch the graph without using a graphing calculator. I have no way of watching you do that or not do that. So if you're using your graphing calculator, you do have to know how to find the horizontal, vertical, x and y intercepts. Your calculator is not very good at showing you those things. So at any rate, horizontal asymptote is going to come from analyzing top degree versus bottom degree. So your top degree is equal to 0 and your bottom degree is equal to a 1. That's because this has an exponent of 1. Anything that does not have a variable, this is just a number, it's called a constant. It doesn't have a degree. So it's a 0 over 1, and when the top is smaller than the bottom, then your horizontal asymptote is automatically y equals 0. Your vertical asymptote comes from whatever is excluded from the denominator. So that's right here. So the value that x can never be is 1. So x can never be equal to 1. Therefore, that's considered a vertical asymptote at x equals 1. So what I'm going to do is go to my coordinate plane, and I'm going to put this y equals 0. So y equals 0 is my horizontal asymptote, and my vertical asymptote is at x equals 1. So I go to where x is equal to 1, and I'm going to draw a broken vertical line. Okay, and that's going to give me my vertical asymptote. Now the graph will be in between. It'll be in here, 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 or here, depending on where I find. This next part is pretty crucial. It'll tell me where it is. So I'm going to switch to blue because this is actually part of the graph. So we'll go to blue here. The x-intercept, remember, you let y equal 0 and you solve it for x. So what you have is y equals 2 over an x minus 1. And if you're going to let the y equal 0, it's 0, 2 over x minus 1. And remember, when you cross multiply those, 0 times x minus 1 is just 0, and 1 times 2 is 2. And that is not true. Therefore, your x-intercept does not exist. So it's a D&E. Does not exist. Well, it doesn't make any sense that I would have one because my x-axis is an asymptote line, meaning you can't touch it. The y-intercept, then, in order to find that, I'm going to let the x equals 0 and solve. So for me to find out what the y value is when the x is 0, I'm just going to substitute in. So I'm going to say y is equal to 2 over 0 minus 1. And I just put a 0 where the x is. So here's what I have. I have a 2 over a negative 1. And that's going to tell me that my y is equal to negative 2. So the y-intercept when the x is 0 is at negative 2. So if I go to 0 and I go down to 2, well, there's where the intercept is on the y. Now, I'm going to tell you that you are okay if you just give me a shape of the graph and that you trace to the other one. You're 1 away, so go 1 away, and then this one is 1, 2 away. So go 1, 2 away, And I'm going to bet that's going to be pretty close to being what it looks like. I'm okay with that because it only tells us to sketch a graph. If some of you want to actually do the rest of it, then the way that I taught you to do the rest of it is to make your XY chart. You take the value that is excluded, and the value that is excluded is this positive 1. X can never be positive 1. You choose 3 above and 3 below. So I need 3 that get bigger. So 3 that get bigger and 3 that get smaller. So 0, -1, -2, and then 2, 3, let's make this go away, and 4. And then I just substitute them in. That's it. I already have the x-intercept or the y-intercept at 0, -2, so I'll just continue going in this direction. So if I put a 2 over a -1 minus 1, I have a 2 over a -2, which is a -1. And if I go back and look at that coordinate, if I go to -1, -1, well, there it is. I just didn't draw it very close. But there it is. And if I put this -2 in, then I have 2 over -2 minus 1. So I have a 2 over a -3. So this one will give me a -2/3. So if I go to -2, 1, 2, then I have a -2/3. That is my solution. And we were pretty close. And so since it asked me for a sketch, it doesn't have to be exact. Same thing going in the different direction. So to get the other branch, I'm just going to substitute in the other 3 values. So what we had was we had 2 over 2 minus 1. So we had a 2 over 1, or 2, 2. So here's 1, 2, 1, 2. So we guessed that one exactly. Then I'll put in the 3. So 2 over 3 minus 1 is a 2 over a 2, which is a 1. So 1, 2, 3, positive 1. That was pretty good also. And then here's the last one, which is the 4. So 2 over 4 minus 1. So 2 over 3. And so I have a coordinate of 4 2/3. So if I go back and look, 1, 2, 3, 4, and 2/3, that was pretty close. All right, and those are the things, all of the things that you're going to need to be able to do in order to graph a rational function. Okay, on the next page, there's some more graphing. So number 3, number 4, and then this one's going to ask you which of the following is the equation of the graph below. The way you're going to look for that, I can pretty much tell, and I'm just going to give you a couple of hints here. So I can pretty much tell, it looks like I've got an asymptote here at positive 2. So that's a VA. It looks like it is at x equals a positive 2. Well, that means that's an excluded value from the denominator. And when I look at these, I see that I have 3 of these. This one, and this one all have 3 excluded from the domain. So this one's out. So what I have to do is determine from the other 3 which one is actually the graph that I'm looking at. When I'm looking at the horizontal asymptotes also, I see that this is a degree 1, degree 1, degree 1, degree 1, degree 1, degree 1. So their horizontal asymptotes are the next thing that I'm going to evaluate. So the y equals, which is your horizontal asymptote, and your horizontal asymptote. 2 of them are the same and 1 of them is different. So this one is a 1 over 1. This one is a 1 over 1. Here are my degrees. And this one is a 1 over 1. So what that means is you had to use the lead coefficient over the lead coefficient. Well, this one's a little different. So this one is a 6 over a 2. So this one has a horizontal asymptote at y equals 3. So I need to see, do I have a line here that's stopping the graph? And the answer to that is no. So what I've done, since that's not actually a part of the graph, I know that this has to be eliminated. So I've eliminated it to 2 choices. And that's where I'm going to stop and let you figure out, well, which one of the 2 is it? Moving on. The next part, number 6, 7, and 8, they're asking you only for horizontal asymptotes. So for horizontal asymptotes, remember, I'm going to analyze the degree of the polynomial. So this one's degree 3, this one's degree 2. So if my top is a 3 and my bottom is a 2, what kind of horizontal asymptote do I have if the top is bigger than the bottom? If the top is bigger than the bottom, then you have a DNE. There is no horizontal asymptote as the top is bigger than the bottom. So I can give you a quick rundown of that. So for your horizontal asymptote, if the top degree is bigger than the bottom degree, there is none. Okay. If the bottom degree, or if the top degree is smaller than the bottom, then it's automatically at y equals 0. And if the top is equal to the bottom, then it's always y equals your lead coefficient over your lead coefficient. And that's what you'll need to analyze for number 7 and number 8. And then the last part, well, that's it. Yeah, that's it. Right, so those are the things that you're going to need to be able to take your little quiz that I'm going to give you on Monday. Okay, so this is your review on Monday that I'm going to assign to you, and then the quiz will be ready for you to take on Monday afternoon. It will be due by the next time you have class, so if you're in my Monday class, it'll be due on Wednesday. If you're in my Tuesday class, it'll be due on Thursday. Okay? If you have any questions, you know that all you have to do is reach out, let me know. I'm available from 10 to 2 just about every single day. Okay? All right, everyone. Be well.